Welcome. So the topic we'll be discussing in this lecture is file system interface. Actually, it is a separate chapter, but we'll be discussing it here in this lecture briefly. So the topics we'll be discussing under this chapter will be file concept, access methods, and disk and directory structures. So the objective of this topic is to explain the functions of file systems, to describe the interfaces to file systems, that is how file system, in what are the different ways file systems can be accessed, and also we'll be discussing about sharing of files, locking, and directory structures. So let us start. Fine. So basically, a file is a collection of information. A file is a named collection of information. So this is how a file is generally defined. But previously, if you remember, in one of the lecture, we have defined the file more formally, something like this. That is, the file can be more formally defined as the operating system abstracts from the physical properties of the storage devices to define a logical storage unit, and this logical storage unit can be called as file. Okay, the operating system abstracts from the properties of the physical storage devices to define a logical storage unit, and this logical storage unit can be called as files. Okay, so this is a more a formal definition of a file. And file, it generally occupies contiguous locations in the memory. File is nothing but some locations in the hard disk. In the hard disk, there are some locations. That location we call it as a file. Okay, but different locations may belong to different file. Okay, so from user's perspective, we need how we will understand. You cannot say that a file starts at track 0 sector 0 and it ends at track 129 and sector 122. If we say like that, it is very difficult to conceive. Okay, so what we do in the sense, what the operating system do in the sense, operating system will will name will 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 give a name for this particular contents which belongs to one particular file. Okay, and so that we are calling that file as a logical unit. It is not a physical entity. Physically, the contents are stored in the hard disks. In everything is stored in some sector. Okay, but referring the content of the file in terms of tracks and sectors may be difficult for a human. So so we create an abstract entity, and this abstract entity or this logical entity will be given a name with respect to the with respect to the related contents, and this name and and this logical representation of the information is called as file. Okay, and file generally occupies contiguous locations. Okay, right. And uh, see, uh, yeah, here one more thing you have to understand. See, this definition says that contiguous logical address space. Okay, so it means that its logical address space is continuous. So logical address space is not the real address space. Okay, in physically it may not be contiguous also sometimes. Okay, it may not be contiguous also, but the logical representation will be contiguous. Okay, and we have different types of file. It may be a numeric. The file may have only numeric data, or it may have only character data, or it may have binary data, or it may have a combination of so many things. Okay, it may make an alphanumeric information. Okay. So so you might have came across different types of files like text files. So whatever we create in a notepad is called as a text file. Any program that we write is called a source file. Okay, after writing the program, we compile. once we compile, the object code will be created. Then the and when you execute, the exe file will be created. So exe is an executable file. Okay, these are some of the different kinds of file. Okay. Coming to the file attributes, every file will have a name, unique name. It need not be unique. Okay, unique in the sense, in the given, what you call, in the given directory it will be unique. Okay, for example, I may have a file with the name as third CSE inside the directory ikfitech. Okay, again I may have the file with the same name, third CSE, inside some other directory, which is ikfi. Okay, so in that case, two files, they have the same name. Okay, so in a given directory, the file will have unique name. Okay, so this name is just for user or the human to identify that file. Okay, and every file will have a file identifier, which is a unique number. Every file will have a file identifier, which is a unique number, which is used to identify the file by the operating system. Okay, and this will not be in the user readable format. This will not be in the human readable format. And there will be a type for every file, whether it's a text file or it's a Java file or it is a PDF file, or what is the type of the file, or is it a image, it's a JPEG file, okay, or it's a GIF file, like that. And location, which location it is stored, okay, a pointer to the location on the device. So here device in the sense, it may refer to either hard disk or the memory, RAM. And size, how much size the file occupies. And the protection in the sense like, what are the read, write and execute privileges, which user can perform read operation, which user can perform write operation, who can perform execute operation. So that is called as protection. And time, date and user identification. Okay, that is at which date and time the file was created, or which date and time the file was finally modified, and who modified it or who created it. So those informations, all these informations are called as file attributes. So a typical file will have all these information. Okay, right? Okay. So, and a file may also have something called as checksum. Checksum is used to checksum is something which is used to ensure that the file is not corrupted. Okay. So if you take a file, at one part of the file, your code will be stored, and that code is called as checksum. Some code will be stored, and that code is called as checksum. And how this code is created, in the sense, this code is created by performing some manipulation or some operation on the content of the file. So assume that finally, the say this is a file, some file, say F1. Okay, so on this file, after the last access, the operating system has performed some operation and it has written a checksum. Okay, now once again when you open the file, once again when some user want to open the file, the operating system will perform the same operation on that particular file, and it will create a checksum. Okay, checksum, and it will compare whether this both the checksums are same or not. Only if both the checksums are same, the file will open. Otherwise, the file will not open. If it is not same, it means that the file is corrupted. Okay, that means in between somebody, anything is stored in a disk only, hard disk only. So at last some user, say user K has written the file. Okay, at that time this checksum was calculated. So after that, accidentally or intentionally, somebody has modified this particular tracks and sector in the hard disk, so that this file has got corrupted, and that is the reason it is creating a wrong checksum. So this checksum is something, it also provides one level of protection to ensure that the contents are not modified in between or something like that. Okay. So this diagram shows uh, This is basically from a Mac operating system. It shows the attributes of a file. What type of file? So here instead of type, Mac OS using kind. It's a text file. What's the size? 1115 kilobytes. Where it is stored, in which path, when it was created, when it was modified. All these details are there. Okay, like that, you can check for any Windows file also. Just click on a Windows file, right click on it and click on properties. So there you will get all these information. Okay, so these are the attributes of a particular file. Okay, and what are the typical operations that will be performed in a file? So file can also be called as an abstract data type. File can also be called as an abstract data type. This is another way of defining file. Okay, so what are the operations generally we perform or a user performs on a file? You can create a file, you can read a file, you can write into a file, you can move the pointer from one location to some other location, that is called a seek. You can delete the entire file itself. You can truncate. Truncate in the sense, the difference between deleting and truncating is, deleting means you are deleting the file itself. It means the file no more exists. Truncate means you are removing the contents of the file. The file will be there, but its contents will be removed. That is called as truncate. Okay. So it means after truncating, the file size will become 0 kilobytes. It means the file exists, the name exists. A file with that name exists, but it will not have any content. Okay. So previously, before truncating, if it is 500 KB, then after truncating, that file will become 0 KB. Okay. Are you getting? But if it is deleted, it means that file itself, before deleting there will be a file with 500 KB. After deleting, that file itself will not be there. So that's the difference between file delete and truncate. And then we may open a file. So opening a file in the sense, it just means that moving the file from the disk to memory. That is called as opening the file. Because originally file will reside on the disk. So open a file F5 means move the file F5 from disk to memory. Similarly, so it means the file is in the memory, we perform some operation, at last I want to close. So closing the file means writing the content of a file from the memory to the disk. Writing the content of a file F5 from the memory to the disk. So that is called as closing a file. And what are the locking schemes available on a file? So basically there are two types of locks are available. One is called as shared lock. The other one is called as exclusive lock. Shared lock in the sense, shared lock will be applied if it is a read-only file, or, or if more than one process want to perform only a read operation. Okay, then shared lock will be applied. Okay, so it means there is a file F, and in that file, if there is a shared lock, say let me call it as SL, it means more than one process can read this file. It means more than one process, say P1, P2, P3, like that, more than one process can read the content of this file simultaneously. Okay, more than one process can read the contents of this file at the same time. Okay, so that is called as what you call as uh, shared lock. Okay, because there is a lock, but it is shared. It is shared among multiple process, and they will perform only read operation. They won't perform any write operation. Okay. Whether if it is an exclusive lock, if it is an exclusive lock, it means that the file is exclusively locked for one particular process or one particular user. Okay. So if there is a file F, and on that file, if there is an exclusive lock, okay, if there is an exclusive lock, say let me call it as EL. If there is an exclusive lock, so this is the file F. If there is an exclusive lock by the process P1, then it means that only P1 can access this file. It means that only P1 can access this file. Okay. So, if another process P2 want to access the same file at the same time, it will not be allowed to access. Then P2 has to wait. until P1 releases the lock. Okay, so then P2 has to wait until P1 releases the lock. Okay, because P1 has got an exclusive lock. So exclusive lock in the sense P1 may perform write operation. So at that time, other users should not be allowed to perform any other operation. Otherwise, the file may get corrupted. Okay, so all these already we have discussed, right, in process synchronization or whatever it may be. Okay, so it is something related. It is actually connected with that. Okay, shared lock means more than one user can access the file at the same time. Exclusive lock means only one user will be allowed to access the file. That is whoever is acquired the lock, and other process should wait. Okay. Other than that, some of the operating system provide the operating system may provide any one of these types of locks. Some operating system provide mandatory lock, whereas other operating system provides advisory lock. For example, if you see Unix and Linux, they provide a mandatory lock, whereas Windows provides a mandatory lock. The operating system Windows provides a mandatory lock, whereas operating system like Unix and Linux provides advisory lock. Okay. So what is that? What is mandatory lock and what is advisory lock? See, with the mandatory lock, what happens in the sense, uh, as I have already, as we already discussed about exclusive lock, if there is a file, if there is a file F, and if a process P1 has if a process P1 has acquired a lock on this file, if a process P1 has acquired lock on the file F, then it means that only P1 can access the file F as long as P1 is acquiring this lock. Okay. Now, if another process P2 comes, P2 will not be allowed to access the file F, and P2 has to wait. P2 has to wait until P1 releases the lock. Okay. So this will be taken care by the operating system. So in mandatory locking, what happens in the sense, this entire process will be taken care by the operating system. So the moment P1 got the lock for F, the moment P1 got the lock for F, now if P2 tries to access F, P2 will not be allowed to access F. So who will be doing that? Who is having the control? The control will be with the operating system. Operating system will ensure that none of the shared resources are getting accessed by more than one process simultaneously. Okay, that operating system will ensure. So that is what is called as a mandatory lock. Whereas in advisory lock, what happens in the sense, operating system will not take care of that. That respective process itself should take care. Okay. So now you consider the same scenario. Now consider the same scenario that P1 has acquired a lock on F and P2 want to access F. So before P2 accessing F, it should check. Before accessing F, P2 should check is somebody else is currently using F or not, and somebody else has acquired a lock or not. Yes. Who has acquired? P1 has acquired. If P1 has acquired a lock, then P2 should wait. It's the job of the particular software. It is not the operating system will do. The particular softwares are responsible. So the process P2 by own, it should check and it should wait. If it is not waiting, that's it. This file will get corrupted, and there will be a penalty for both the users P1 and P2 because they will get a wrong copy of the file. Okay, so the point is, in case of shared access, if the control is with the operating system, then that is called as mandatory lock. If the control is with the respective software, then that is called as advisory lock. So these are typical types of files that are normally used. Executable file which has these extensions .exe, .com, .bin, all these things. Object file, typically it will have the extension .obj or .o. Source code file, it depends on the programming language. It has extensions like .c, .cc or .java, .asm, .a or .py Python. Okay. Batch file, it has extension .bat or .sh. So batch files are something like shell script, which we have discussed. Okay, in Windows also you can create a batch file. The batch files in Windows will have extension .bat. Text files will have the extension .txt or .doc. Okay, word processing. .doc or t or .tex or .rtf, library files .lib or .dll, okay, and print or view file either .ps or .pdf or .jpg. Archive is something like a repository. It is normally used for like something like a backup storage of files. It has extension like .arc, .zip or .tor, and multimedia files have extension like .mpg, .mov or .mp3, all these things. Okay, right. So now let us discuss the structure of the file. So there are different types of file structures available. Sometimes the file may not have any structure at all. It's just a sequence of words or bytes. And some files may have some simple structure like it's a collection of lines, or 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 it may have or it may have some features of fixed length or variable length. Some complex structures may include some formatted content. Okay, like serial number, name of an employee, the year of joining, date of birth. All these things are some format, some specific format, and it may follow that particular format. Okay, fine. And file accessing mechanism. There are two types of access methods generally available. One is called as sequential access, the other one is called as direct access. So with sequential access, what happens in the sense, if you want to access the nth location, say this is the nth location, if you want to access the nth location, so then the operating system has to access all the previous zeroth location to n minus 1th location. And then only you can access the nth location. Okay, you cannot directly access the nth location. So that type of file accessing is called as sequential file access. Okay. So if I want to, if you want to access 10th location, if a particular process P1 want to access 10th location in a particular file, then it has to access starting from 0th location, 0, 1, 2, 3 up to 9th location, and then only it can access the 10th location. It cannot directly jump to the 10th location. Okay. So that type of file access is called as sequential access. Okay. Right. And the next type of access is called as direct access. The direct access, with direct access, the particular process can directly jump to any location. It need not follow any sequence. So in this case, if it want to access the nth location, it is not that it has to access all the 0 to n minus 1 location. No, so directly it can access the data at the nth location. Okay, so that is what is called as uh, what you what is called as direct access. Okay, so you can see this code here. So unless you reach that particular location, you have to keep on perform read next, read next, read next, or whatever it may be. Okay, so how long you should do means until you reach that particular nth location. Whereas with direct access, you can directly position to nth location and then perform a read operation. So that is how these are the two general file access methods. Okay, there are also some other access methods, which is something called as index access method. So index access method is something like, in the book you might have you might have seen a typical textbook. At the back end there will be index, and if you in the index there will be different topics and the numbers. Okay, by referring to a topic you will find the number. Okay, then directly you can jump to that topic and you can read that topic. Okay, it is something like this. So index accessing, how it works in the sense, say a particular file contains several records, like it contains hundreds or thousands of records. Okay, and all these so this is the actual file. Okay, so this is the actual file. It contains hundreds of thousands of records about say individuals, their name, first name, last name, social security number, age. Some data are there. So it contains it contains informations about so many users, hundreds or thousands of users. Okay, now index reference. So I mean, index access methods. What it will do in the sense, it will maintain an index file for every file. It will maintain an index file. The index file will have minimum two columns. One is any one of the attribute. Here we are considering we are having the attribute last name, and the other one is the record number or the actual address, which address this particular record is available. Okay. So say for example, so this file contains say 1,000 location. Okay, then then the entry about Adam, it is in which location? It may be in the second location. Entry about Arthur, it is in which location? It may be in fourth location. Entry about Asher, it is in which location? It may be in eighth location. Like that, everybody's location data will be stored here. Entry about Smith, where it is? Maybe it may be in 19th location. Okay. So now, if you want to identify the record of Smith, just first check in this index file sequentially where is Smith and identify that. And once you did that, you can directly you will know you will come to know the uh, address or the you will come to know the logical record number or the address of Smith, and then directly you can access that particular record from the file. Okay. So this type of access methods is called as index access method. Next we shall discuss about the directory structure. So all files are normally stored inside the directories. Files are normally stored inside the directory. So we can say directory as a collection of files. Directory as a so it's a it's a named what do you call a directory will hold a group of file. Okay, and it is something like a namespace. A directory is something like a namespace. Okay, so a group of files are put together in a particular space of the memory, and that space was given a name. Okay, and we call that as a directory. Generically, it is called as directory. So see, generally we divide the hard disks into several partitions. Okay, even you can say each of the partition as one directory. Even you can say each of the partition as one directory. So this diagram shows there are three hard disks: disk one, disk two, and disk three in a typical computer. Okay, disk one is divided into two partitions. Okay, partition A and partition B. So you can say that all the files in partition A will come under one directory. All the files in partition B will come under one directory. Okay, and disk 2 and 3, it's not partitioned. It is treated as one partition. The entire disk 2 and 3 is treated as one partition, that is partition C. So all the files in disk 2 and 3 comes under one particular directory. Okay, so even the partitions also can be treated as a directory. And what are the operations that we can perform on a directory? Like how we perform operations on a file, most of the similar operations we can perform on the directory also. The directory will have group of files. So to search a file, to create a file, to delete a file, list a directory. In Linux we have ls, right? We have discussed ls-l, which lists the contents of a directory, rename a file inside the directory, traverse the file system. What are the files? Just traverse through it, right? Okay. So these are the typical operations that can be performed on a directory. Why do we create a directory? See, basically we create directory for efficient organizing of files, and also and also uh, and also it groups things in a logical way, and naming related information and grouping related information put together and giving it some name. It will be convenient for the user to manage the contents of the uh, to manage the information. Okay, if there is no concept like directory, then everything will be a file. Then maybe in your computer you may be storing hundreds or thousands of file, and there may not and it may not be properly organized. So generally we use directory for organizing the thing in a proper way, so that the user will feel convenient of using it, right? Okay. So directory basically what it does in the sense, it groups related properties uh, of files. Okay. So grouping of logical informations of files. For example, you can put all Java programs in one directory, all games in another directory. Okay, so it forms from, so directory makes it convenient to make some logical grouping of files based on its properties. Properties may include the type of the file, or about for what operation it is used. It depends. Okay. It, yeah. Then let us see some different types of directories. So the primary type of directory is called a single level directory. With single level directory, what happens in the sense, there will be only one level of directory. That is, in the top level, there will be some directories, and after that there will be files. I mean, inside the directory there will be files. There is no concept of subdirectories. With single level directory, there is no concept of subdirectories. At the top level, you have directories, and then immediately you will have files. Okay. The problem with this type of directory structure is there is a naming problem, and also there is a grouping problem. Naming problem in the sense, say for example, I may give, if I want to give same name for two files, that is not possible here. Okay. Because there is only mm, I mean, you can give two, you can give uh, same, you can give different names. uh, I mean, you can give same name for two different files which are in different directory. One is in cat directory, another is in data directory. You can give different name. Okay. But you cannot give same name. uh, you cannot give same name for a file in the same directory. Okay. Or you cannot create another directory with the same name. Already there is a directory cat. Here I want to create another directory cat. That is not possible. Okay. Right. Say this particular system is used by more than one user. Assume this particular, it is a multi-user system. Let us assume it's a multi-user system. Say two users are using this system. Say user one is using this system, and also another user, say user two is using the system. Okay. Two users are using this system. Okay. So now this directory structure, say it is very much convenient for user one. Okay. Now say that user two also want to create a directory called records. There is a directory here, records. Okay. User two also want to create a directory called records, and he want it to be what do you call it? It is only for this particular user. Okay. It is not for user one, but that is not possible in this case in single level directory, because already there is a directory records. You cannot have another directory with the same name, right? So that problem is called as naming problem, and also there is a grouping problem, because directly inside the directory we are keeping the files. You cannot further make any groupings. You cannot further make any groupings. Okay. So mm, for example, inside these records, i may have I may have some 10 records related to student. I may have another 10 record related to employee. Okay. I may have another 10 records may be related to grocery items. Now you cannot, there is no way to group, because there is only one level you have. So everything is under records directory. Okay. You cannot make another directory, and another subdirectory, and put all students record there, and another subdirectory for all employee, another subdirectory for all grocery. So that flexibility is not there. So that is the drawback with this single level directory. In two level directory, what you have doing in the sense, for different users there will be a different set of directories, and inside that they will be storing the file. So the user one is having these directories. If you want, he can create more directories, and then inside that he can store the file. Similarly, user two has these directories, user three has these directories, and user four has these directories. Now here you can see that there is a directory A for user 1, and also there is a directory A for user 2, but these two A's are not same. So this A belongs to user 1, and this A belongs to user 2. Similarly, you can see there is a directory test for user 1, and there is a directory test for user 3. Okay. So this test is different from this test, right? So so basically, here the file names are identified by using the path name. So if you want to refer to this particular test, then you have to follow this path, user one test. If you want to refer to this particular test, then you have to follow this path, user 3 test, right? So here it allows us to have same file name for different user, but that is not possible under single level directory. Different users cannot have same file name. Okay? And searching is more efficient with two level directory. But here also we don't have grouping capability because there is only two levels. Beyond two levels we cannot go. So further grouping is not possible. So that is one of the drawback with this two level directory. The next is tree structure directory. With tree structure directory, you can go for any levels. Okay. So at the root level, you have these directories, say spell, bin, and programs. Then under spell, you have these subdirectories: stat, mail, and distance. So stat has one file, distance has another file, whereas mail has some subdirectory. So this is one form of grouping. So mail has a subdirectory and which contains these many directories: program, copy, print, and experience. Okay, exp. So this exp contains a file, but all other subdirectories contain further subdirectories. You're getting? So this provides more sophisticated grouping or more fine or subtle level of grouping, right? Okay. So yeah, so this is how directory is structured, right? Fine. That's it about this particular topic. Let us stop here. So generally it speaks about the file system, how file is created, how we define the file, what are the attributes of a file, okay, and what's the locking mechanism, and what is a directory, and how what are the various directory structures were available, right? Fine. Let us stop here. Thank you.